Hello, and welcome to our channel, your one-stop destination for all things GED math. Whether you're a student preparing for your GED or just a math enthusiast looking to challenge your number-crunching skills, you've come to the right place. We're dedicated to helping you understand and solve complex math problems that you may encounter on your GED test. We break down each problem into manageable steps, providing clear, easy-to-understand solutions. We believe that a good understanding of the problem and the process is just as important as finding the right answer. So we not only focus on the solution, but also on the why and the how of the problem. We're excited to have you join our community of math enthusiasts. If you find our content helpful, don't forget to give our videos a thumbs up and hit the subscribe button. Your support helps us create more content for you. Now, without further ado, let's dive into today's problem. A challenging GED math problem about a train journey. Grab your calculators and let's get started. Welcome, math enthusiasts and GED students, to a journey of numbers and logic. Today, we're stepping into the exciting world of GED math problems. These are the hurdles you may encounter on your path to achieving your GED. But fret not. With a dash of patience, a pinch of perseverance, and a generous helping of number crunching, we'll navigate these challenges together. Now let's delve into today's problem. Picture this, a train chugging along at a steady pace of 60 miles per hour. It's a sunny day, the landscape is a blur of green and blue, and time seems to be flying as fast as the miles under the wheels. Now, this train keeps up its pace for 3.5 hours. We're not concerned with where it's going or why it's maintaining this specific speed. Our main question is, how far will the train have traveled in these 3.5 hours? This problem might seem simple at first glance. We're given the speed of the train, that's 60 miles per hour, and the time it's been traveling, 3.5 hours. But we're dealing with a mix of whole numbers and fractions here, which can be a bit tricky. But don't worry, we're not about to let a little fraction intimidate us, are we? No, we're going to break this problem down step by step and find our way to the solution. We'll explore how to convert the speed and time into a form that's easier to work with, how to multiply these values correctly, and most importantly, how to interpret the result we get. Math, after all, is not just about finding the right answer. It's about understanding the problem, knowing the process, and learning to think logically and systematically. So, as we venture further into this problem, keep your mind open and your calculator at the ready. So, how far do you think the train has traveled? Hold that thought as we break it down. Welcome back to our channel, friends. Today we're back with another interesting session. Now, before we jump into solving, it's crucial to understand what the problem is asking. We've all heard the saying, a problem well stated is a problem half solved. And that's what we're going to do right now. Break down our GED math problem and understand it thoroughly before we think about diving into the solution. So let's imagine we're on a road trip. We're cruising along the highway, and we know how fast we're going and how long we've been driving. Our task? To figure out how far we've traveled. This is the essence of our GED math problem. It's about the relationship between speed, time, and distance. Now let's take a closer look. Speed, time, and distance are interconnected. They're like three friends who always hang out together. You can't have one without the others. They're part of a formula that's as old as time itself. Distance equals speed times time. Or for those who prefer it in shorthand, D equals sit. Let's take a moment to appreciate the beauty of this equation. It's simple, yet it explains a fundamental aspect of our daily lives. Every time we drive a car, ride a bike, or even just walk, we're living this equation. The faster we go, the more distance we cover in a given time. And the longer we travel at a constant speed, the further we go. That's the power of mathematics. It helps us make sense of the world around us. But back to our GED problem. It's asking us to find the distance. We know the speed, that's how fast we're going. And we know the time, that's how long we've been traveling. But the distance? That's the unknown we're trying to figure out. So now that we understand the problem, we're halfway there. We've broken it down, explored the relationships between speed, time, and distance, and identified what we're being asked to find. So we know that we need to find the distance and we have the speed and time. Now we can proceed to solve it. Before we end, I'd like to remind you all to hit the like button if you found this video helpful. Don't forget to subscribe to our channel so you never miss out on our future videos. Armed with our understanding of the problem, it's time to tackle it. The problem at hand involves a train traveling at a constant speed, and we need to find out how far it has traveled. We know that distance equals speed multiplied by time. The speed of the train and the time it has been traveling are both given, so we can simply multiply these two values together to find the distance. Let's break it down. First, we need to identify the speed of the train. The problem states that the train is moving at a speed of 70 miles per hour. That's our first piece of the puzzle. Next, we need to establish the time the train has been traveling. The problem tells us that this is 3 hours. That's our second piece. Now, armed with these two pieces of information, we can proceed to solve the problem. Remember, to find the distance, we multiply the speed by the time. So 70 miles per hour multiplied by 3 hours. To multiply these, we simply multiply the numbers as they are. 70 times 3. Don't worry about the units right now, just focus on the numbers. 70 times 3 equals 210, but we're not done yet. Remember, we left out the units when we did our multiplication. Now it's time to bring them back in. Our answer of 210 represents the distance the train has traveled, and the unit for distance in this case is miles. So the train has traveled 210 miles. Now it's important to understand why this method works. When we talk about speed, we're referring to how far something can travel in a given amount of time. So when we multiply the speed by the time, we're essentially calculating how far the train can travel in that time. This is a fundamental concept in physics, and it's used in many different scenarios, not just train problems. For example, if you know how fast a car is going and how long it's been driving, you can use the same method to find out how far the car has traveled. In this case, the problem was straightforward because we were given the speed and the time. But remember, this method can also be used to find the speed if you know the distance and time, or to find the time if you know the speed and distance. It's a versatile tool that can be used to solve many different types of problems. And there you have it. The train has traveled 210 miles. Did you get it right? Let's take a moment to revisit the key points from today's problem. We've journeyed through an intricate GED math problem together, and now it's time to distill the essence of what we've learned. Firstly, we delved into the importance of understanding the problem. This isn't just about reading the question. It's about comprehending the nuances, the hidden implications, and the variables at play. It's about dissecting the problem and identifying its core components. We've seen how this initial step can set the stage for a successful resolution. Next, we touched on the correlation between speed, time, and distance. This is a fundamental concept in math, and it's crucial not just for this problem, but for a wide range of questions you may encounter. Remember, speed is simply how quickly an object moves. It's the distance traveled over a given period of time. Understanding this relationship can help you manipulate these variables to find the missing piece of the puzzle. Then, we broke down the problem into manageable chunks, tackling each step methodically. We started with the given data, applied our understanding of speed, time, and distance, and gradually built towards the solution. This step-by-step approach is a powerful tool that can help you navigate even the most complex problems. Lastly, we explored the solution, analyzing how and why our method worked. We didn't just find the answer, we understood why that answer made sense. This level of comprehension is what transforms a good math student into a great one. So to wrap it up, today we've learned the importance of understanding the problem, the relationship between speed, time, and distance, and the value of a step-by-step solution. But remember, these aren't just tools for this particular problem. They're skills you can apply across a wide range of math problems. Remember, understanding the problem is as important as knowing how to solve it. Well, that's all for today's GED math problem. Just remember, the secret sauce to mastering these problems lies in practice. Yes, practice. The more problems you tackle, the more familiar you become with the different strategies and techniques to solve them. Now, I won't lie to you, it's not always going to be a walk in the park. There will be times when you'll feel like the numbers are dancing around, but that's when you need to hold your ground, take a deep breath, and keep at it. Trust me, with consistent practice, even the most challenging problems will start to unravel themselves. And remember, every problem solved is a step closer to mastering GED math. So don't shy away from those problems, embrace them. Keep practicing, and soon GED math problems will be a breeze for you. Until next time, keep your numbers up.